So first of all, thanks being here. Uh, Also thanks to BBF. I'm honored to give you an update on not 2 levels higher, but a few levels higher. So I'm going to give you an overview of the evolution to autonomous networks, which is actually fully linked to my previous colleague. Just to be clear, I'm not going to talk about 25 gig, 50 gig, 100 gig, 200 gig. That's for other people. I'm even not going to talk about SDN controllers anymore. So that's why I say let's take it a next level. Okay, so I'm not going to spend a lot of time on all the slides. You will get the slides. You can read them going home. I just want to highlight that these days we can think that the networks become simpler, but the paradoxical effect is happening. They are becoming much more complex, meaning virtualization, cloudification, all those type of technologies we have been talking about the last days. A second is that our end users become much more demanding. It's not about high speed or voice calls anymore. It's about gaming, working from home, connecting enterprises, connecting an enterprise or at home, small, medium enterprise to the cloud and that sort of things. That's why we believe that actually automation becomes just very important. If not, you might get stuck in developing your business. Second, talking about network automation, still a lot of people think about improving the OpEx, which is true, of course, being faster in delivering services, but actually within Nokia, and that's actually confirmed as well by renowned analysts like an Analysys Mason, it's not only about the OpEx part. It's also about how to monetize your network, how to develop new services like gaming, by which you can increase your ARPU. So in summary, it's not about OpEx only, it's about enabling you as operators to monetize the network. And I will have a bit of the same demo on that one. As I stated, these days, analysts talk about network automation software. If you look to the most recent paper, analysis of Analysys Mason, you will see or find that picture. What that picture actually tells us is that we are used to talk management systems, fault management, performance management, which will stay there forever, actually. You always need to configure systems, do fault management. But what you see as well is the entry of domain controllers. So I'm not talking anymore about SDN controllers, and a lot of people in the audience know me. We are talking about domain controllers, because it has little to do with where we started with SDN. It's not about separating control plane and forwarding plane and user planes anymore. It's about automation. It's about closed loop technologies to realize the expected of the network. So you see that this is a growing trend, an investment by the CSPs investing in domain controllers. And a second trend, interesting trend actually, is this one, is network slicing. So network slicing to monetize the network. And this is actually the strategy I would like to explain and share with you today, because we are highly connected with domain controllers and with network slicing. This is something you can read going home or next week in the office. That are the network automation goals. I don't want to spend too much time on that. You can read it offline. Just to indicate, indeed, it's more than OpEx. It's about creating new service opportunities through automation. With this slide, I want to spend a bit more time and effort, and Mauro, you will like it, I hope. I do this for you, Mauro?
I saw it. I got a preview. I liked it.
No. So this is our, yeah, this is our vision. So it's a vision. So that's where we are evolving to within the company I work for. But this is also being echoed actually by other standardization bodies like a TM Forum, like a NETSI. Marcus, my colleague, was talking about that yesterday. So what you see on that slide, it's a quite complicated slide, I know, but what you see here is at the core, you have closed loop automation. So within the telco industry, we entered the era of control. Management systems are outdated. We entered actually the era of controllers, meaning, as my colleague from Zone explained, you do not just configure and wait till you get an alarm. Now you go in control, monitoring your system, based on that feedback, take corrective actions. That's exactly what a controller means in any other industries, chemical, automotive, and the likes. Of course, those control loops are AI-driven. So actually, to learn how a network is behaving, we are utilizing AI in order to, for instance, predict an error will happen within a month, and we have 1 month time to actually correct it. That's a move to controllers, moving to predictive networks rather than reactive networks. On the left side, you see intent-based networking. So we are used, as they call it, in intent-based networking, RFC. So this is very well defined. It's RFC 9315. Intent-based networking is actually bringing it at such a high abstraction level that you don't need to know anymore how to configure the system. So you just declare what you expect the system to do for you in very abstract terms. And it doesn't stop there. It's actually based on control theorem, where actually the intent, which is sort of microcontroller, will check by itself and will make sure by assurance that expectation is delivered at any point in time. My friend Mauro already talked about digital twin. So we are putting the digital twin in between designing new intents and the production network. To do what? To validate whether a new service is working before you impact the real network. But it's more than that. We are working, and you have been seeing that from my colleague Benoit, we work AI-driven planning tools where actually we are able, based on real data in the network, we are able to predict when you go outside with capacity based on AI and based on building a digital twin of that network segment. So we are creating a digital twin. Last week, I had a meeting with an operator from Asia Pacific. He said, yeah, you are talking science fiction, might be true, but we have all this already today. It's not final, it's still under development. It will take 10 years as well to get there, but we have the first building blocks of AI, digital twins available in our portfolio. So it's not science fiction. On the right side, you see the whole apps concept, the apps marketplace, the apps ecosystem. An app could be, for instance, to predict that a failure might happen in 1 month from now. So those apps, going along with marketplaces, can be developed by my company, not my company, but the company I'm part of, just to be clear, and others, third-party developers. So we are offering an open platform, SDKs, development, software development kits, so that anyone can actually develop their own applications, which we can then onboard in the closed loop of the controllers. To bring it back to Earth, This is our simplified view on how to decompose a network. So there are only two layers. It's a flat architecture. You have an end-to-end service operations layer, and you have controllers. We opted to go for controllers for the home. I think we spend a lot of time on Wi-Fi these days. I don't need to explain that. Controller for the access network. We have one for the fixed and one for the mobile. The transport network, we have a controller for both the IP domain as the optical domain, and we have a controller for the core domain. But the core engines of evolution to autonomous networks are the controllers. And this is overarched by an orchestration function. This is the model we apply within our company. But actually the most important I would like to share with you today, that this is being echoed by TM Forum. So probably you know TM Forum from defining the APIs on the OSS BSS level, but meanwhile TM Forum has defined the reference architecture for autonomous networks, where you see actually the same decomposition. What they call decomposing it in autonomous domains. A can be home, B can be access, this one can be IP. Overarched by one orchestrator service operations layer, I leave for now the business operations outside. But this is not just a drawing. There are a lot of concepts behind that drawing. So actually, the concepts are two layers only, but the most important concept is actually decentralizing the intelligence to the controllers. Because indeed, the moment you go in AI-driven operations, in closed loop, machine learning, you cannot do that across all domains. You need to do that within your own domain, because that's where the knowledge, where the expertise is about. So that's why those domains are called autonomous domains. They call it actually decentralizing the intelligence to the domains. Those domains are intent-based networking domains, do have all the data they need to apply AI-driven operations, and they realize closed-loop automation. For the company I'm working for, all those domains are realized through the 4 domain controllers I was referring to, and are multi-vendor domains. Meaning there is only one domain controller, and the domain controller is multi-vendor, exposing to the node on the I3 interface a vendor-agnostic experience. Another key element is that this reference architecture for autonomous networks also defines actually one of the debates we have in industry since long. It's not only about talking, communicating north-south over the I3 interface, but what they say, neighboring domains know each other. They talk with each other. So actually they defined cross-domain collaboration. So not going over the orchestrator to the other domain, they go straight, but only for neighboring domains. There was a discussion on intent-based networking. Keep the previous in mind. So this plot, intents are at all 3 levels. So you have business intents, you have service intents, and you have resource intents. The resource intents are actually realized through the domain controllers as autonomous domains. But you have 3 levels of intents. At the business level, translating it in the service level, so translating it into the different resource levels through the controllers. But to me, the most important is that all those intents do actually realize a closed loop. So they translate, do not only abstract from north to south, they have the knowledge, they build the knowledge, they learn the knowledge through AI, ML, and actually they are able to close the loop to go in self-healing, self-assurance under the hood of the intent. So this is a completely new paradigm, because each layer becomes an autonomous layer, driven by using AI, ML, and by closed-loop automation. Within industry, there's a very high momentum these days on autonomous networks. So there is a new initiative as part of TM Forum, defining the autonomous domain, autonomous networks reference architecture, but not only the reference architecture, but also working together to define it actually. So the company I'm part of signed it up. Today we have 46 participants. My key message here on this slide is that don't think that all goes in one step. So TM Forum clearly defined actually 6 levels of autonomy. And actually all the people, all the companies who are signing up for this reference, this manifesto, agreed actually to list where they are in terms of autonomy. Talks with customers, with operators I have on a very regular basis. They want to have, for instance, be at level 3 by 2025. That's the way it goes that today. You see here, intent is at the key of moving to autonomous networks. To map this on a more end-to-end scale, I'm giving a bit of a summary. So moving to AI-driven operations, autonomous operations, systems which learn themselves through AI ML. And I'm not referring here to chatbot and the likes. I'm really about learning the context of the network it's operating in. So it's learning the network. So it's the brain of the network. So trends, and within the company, we spent a lot of effort moving all our products to intent-based networking. Another key element is observability, and I have to say that within industry, this is still a bit of an issue. I tell you why, because the more you abstract, the more you lose control. It's a very weird experience for operators, actually, that the machine is controlling their network. So this is one of the key, let me call it, issues we still need to fix in the industry, bringing actually the right observability that operators do not feel out of control. AI-driven operations, closed loop, I think I already stated that. And as you see here, you have closed loop. And closed loop is not really something theoretical. I repeat, it's already used in many other industries. It's part of control engineering, control theorem, where indeed by feedback, by analysis, by intent, you actually close the loop to assure that the network delivers per intent in very abstract terms. We go beyond that. I said a few levels higher. You can imagine that the moment the controller knows and learns a lot about the network, it can even suggest how to operate the network. It's like entering your car. It's my car. You push the start button. At Friday evening, it tells me, are you going to your parents? I know how that goes, but for instance, this evening or this afternoon, it will ask me, you want to go home? I just have to say yes. So by moving this intelligence into the controllers are able to suggest to the upper layers what to do. This is called intent suggestion, intent ingestion. All concepts which are defined actually. So this is a picture for bring it holistically, using controllers, the autonomous operations, service operations through AI. Let me not spend too much time on that. You can take that as a reference. One of the key elements in making networks predictable, in making networks self-driven, like a self-driving car, we are not changing business to develop self-driving cars, but if you go into the technology of a self-driving car, you will see exactly the same concepts. Key here is prediction. So you need to be able to predict. If you are not able, you can never go autonomous. So we spent a lot of efforts in our company on defining prediction models. Prediction models which actually go by learning the network through streaming. So I'm happy to see that Broadband Forum actually is starting an activity on data collection, because this is quite complex. This is not just streaming, it's really intelligent streaming. Measuring KPIs, and from those KPIs build behavioral models, prediction engines, and proactive remediation. That has been demonstrated by my colleague this Monday. So we have use cases already on that, which you see here, where actually we are able to learn with 4 months data. So this is data intense, 1 month ahead. And the probability that it will happen is 5 nines. So you have 1 month time to do something. Another example, 1 month learning gives you a 1 week prediction. That's why this data collection, this telemetry is so important. I would say data is king here. Okay? So this is how it works with our controllers. So you have actually the controller intent, very abstract. For instance, we have a deployment where we manage and control the entire access network, which is a very complex one in that context, because it's a leaf-spine architecture with 4 intents only. Only 4. Create something, create service 1, create service 2, create service 3, period. All is abstracted. You know VLANs, physicals, is it in coax, is it coax, copper, all is abstracted. Even the resource control is in the controller. The upper layer doesn't know anymore about VLANs. Just a service, period. And this is actually enabling quite a lot of new use cases, and I will explain one. Within the company, we also changed our lexicon. We thought FCAPS is not representative anymore. Moving to self-healing, self-assuring networks. So we changed actually radically our lexicon. This you will find for all new products. Meaning that it's not about FCAPS, it's about slicing the network, discovering assurance, self-assurance, self-healing, predicting the network, optimizing the network, and the likes. So this is a next level next to FCAPS, a few next levels higher. So we are working within the company to have all our products, controllers actually aligned with that, including our orchestrator. This is a bit of an overview of how a controller looks like. So a controller, domain controller, has intent-based networking engines, but more important, has the intents, has workflow automation, has assurance analytics engines in the controller, does resource control automated. For instance, for fiber, we are in an AI-driven way, we are optimizing dynamically, real-time, the PON bandwidth. We use AI ML in the controller, and we are able to slice and share the network. Slice is, I will demonstrate, sharing is sharing the same access infrastructure amongst different virtual operators. And all the controllers have their own data store. Doesn't mean we keep the data here. We are able, it's missing here, to stream actually through Kafka data sets, unified, normalized, vendor agnostic, subsetted to the upper layer. And last but not least, you can actually develop your own apps through open APIs on that controller. So this is how intent-based networking looks like. I think most of it I said already, but the most important thing is actually intent defines what you expect the system to do. So not the nerd knobs, as they call it in that RFC I was referring to. It's abstracting to the upper layer. It's translating into the nerd knobs, the bits and the bytes. It's passing over a virtual representation, a digital twin, to test, validate what-if scenarios before applying it on the real network. And then the intent will instruct the network to start streaming telemetry. We are streaming in a common data lake. We apply on that data lake insights, monitoring, and next steps are doing self-assurance, self-healing, self-prediction, self-optimization through AI, machine learning, prediction, and the likes. And actually, the whole idea that this is closed within the controller. So it's not going up anymore. There will be no PON alarm going up in that context. It will say you expected to deliver service A. It will say service A is whatever we do not possible, period. Let me move for the, can I have 5 minutes still?
Sure. Yeah, I've got a bunch of
to
questions.
network slicing. So within the company, we are working on network slicing actually to deliver premium services. So this is real. We demonstrated that even last week at Mobile World Congress, but we do already more than a year. This is actually creating slices to deliver premium service like gaming, home office, working from home, enterprise connectivity, connecting it to an enterprise, education, health. We create end-to-end slices, virtual networks across the physical or physical plus virtual network. But it's not about creating actually only the slice, it's also about assuring the slice. So it's not creating the piece part in the home, piece part in the access, piece part in transport. No, it's treated as really an end-to-end network, including optimizing it, including doing the service assurance through intent-based networking. So this is the way we developed it. So there is a create slice. We go to a transport slice controller. Why we wanted to start from what has been defined in 3GPP, because 5G network slicing is already defined in mobile. So we extended actually this transport slice controller, adding the fixed access and adding actually the home as well. Because if you look to the slicing, most probably the most important point or the most problematic point is the home, is the Wi-Fi. So it's important to have the home integrated into that end-to-end slice context. And that's what we do with our solutions. So this is a bit a demo we deliver. So you have the home, you have a server, whatever it might be, the internet, you have the Wi-Fi network at home, you have the PON network, you have the IP network. So most probably there will be connection. I think that's not the problem today. The problem is that connection good enough for delivering the expected service like gaming? And then we talk about latency more in specific. And actually it's not mainly about low latency, just to be clear, it's deterministic latency. So there is a big difference and confusion in industry that for gaming we would need very low latency. That's not true. We need deterministic latency, meaning it's always the same. It's a huge difference. Yeah? But assume it's not okay because my wife or my son are doing other stuff I'm not aware of. Maybe I don't want to be aware of. But indeed, it might impact the experience as we were talking about at home. So what we do is actually we create an end-to-end slice through slicing APIs, creating a slice from the home over the network, including Wi-Fi on IP network, so it's treated as one end-to-end slice or virtual network. That enables as well new business models. So an end user, a gamer, might pay for gaming service, but a company like Nokia might pay, for instance, Deutsche Telekom, to provide to its employees a better working from home experience. And also go by slicing. By the way, this is what we deploy today in the APAC region. Now, you can say, look, yeah, what's in it? So we started with on-demand slicing. What is so specific to slices is that they are dynamic, meaning we are used to triple play services, high speed, voice, whatever. They are there forever, almost. Till we retire, they are there. With gaming, it's completely different. You need it for a few hours and then you drop it. So the network will be approached in a different way. It will be approached more dynamically, which you need to cater for, because dynamic management of networks is completely different than static management, completely different. And that's what we cater for with on-demand slicing, but we took already next steps. As part of Evolus to autonomous networks, thanks to our home controller, we are able to, by device fingerprinting, detect, you connect a PlayStation console, and the slice will be created automatically, autonomously. So we detect in the home, you connect a PlayStation, and we will connect the PlayStation by creating a slice to the PlayStation server, automatically, no interaction. The same for traffic. So with our home controller, we are able, through AI, to learn which traffic is being used in the home. It's an AI use case. So we are able to detect you are using at home Teams. We have a use case, we demonstrate that with our home controller. We are detecting that, and we create automatically a slice if you are doing a team session for your work and you don't want to be interrupted. We create automatically by detecting you are using Teams to your company corporate team server, giving you higher bandwidth, guaranteed bandwidth, higher user experience. And we didn't stop there. That's my last slide, I believe. So last week at Mobile World Congress, we demonstrated what we call multi-axis edge slicing. So with slicing as it's approached today, you traverse the slice through the entire network, from home, access, transport to the core. That's not network economical, especially not for enterprises. So we are today able to create slices which are closed, if I may call it like that, on the edge. So they are not traversing the network anymore, meaning the network economics are much better, and two, the latency is lower, because we stop it at the edge. And then the second element, so I was explaining edge versus end-to-end, is multi-access. So we demonstrated together with one of our customers, you see Etisalat, a use case to have multi-access slicing, meaning a slice across fixed wireless access. One slice offering the same experience wherever you are. You are using your mobile, you come at home, we direct actually the traffic for that slice to fixed over Wi-Fi. And last but not least, those edges are equipped to deploy your enterprise apps. So we have an We did a press release last week, 2 weeks ago, with A1, an Austrian operator, the Austrian, and Microsoft, to actually equip the edge with Microsoft Azure, so you can actually deploy your Microsoft apps on the edge, which you connect to by slices. Key takeaways, automation, I think that's clear. We entered another area, so it's not about open flow anymore. Separating, by the way, it's that. Not about separating control from data plane. So we go domain controllers, more aligned with control engineering. TM Forum is the reference, and I invite BBF really to connect with them, to link with them, because they are a few steps ahead, I believe. By the way, Marcus also presented yesterday ETSI 5G, fixed 5G work. Actually, ETSI copied TM Forum with that respect. So you will find the same drawings, architecture in ETSI copied from TM Forum. AI, use case driven, don't boil the ocean, so go step by step. And last but not least, automation to monetize your network. That's it.
That was. I have a bunch of notes here, and why don't, if anyone has any questions, come up real quick. And Dean has some, and so does Bruno. And we're a little bit over, but that's okay. We're just eating into our lunch, so.
Okay. Sorry.
B before D. We'll start with Bruno, then Dean, I guess. Oh, yeah. Good point.
Thanks, Kurt, for the presentation. I have a question related to the TM Forum that you mentioned at the end. That's TM Forum and the architecture that you show. There are 3 different interfaces. That are all them specified at TM Forum, or only part of them?
Very good question. So thanks asking, Bruno. Let me show up the slide. So actually, we all know TM Forum from defining the OSS BSS interfaces, which are defined by TM Forum. In that case, they are not defining what we call here the I3 interfaces. So the I3 interfaces are the north-south interface between an orchestration and the domain controllers. This is actually defined by the specific standardization body. So where I'm driving to, I'm trying to do at least my best, is driving for the fixed access domain I3 to BBF. So actually the I3 interface for broadband access should be the TR411 I2 interface or next levels. The same for IP. For IP, this is IETF, no doubt. So the domain specific standardization bodies, if I may, drive their own I3 interface. With that nuance, they are all intent-driven interfaces, meaning you cannot really standardize them. You can only standardize the semantics, the meta model of those interfaces, because they will change per operator, actually. Again, one operator I was referring to, we did that with 4 intents. We took 4 months to define them with that operator because it's fully matched with their business logic. So you cannot standardize that. Or you say all operators use actually standard interfaces. But yes, it remains within, so that's what I'm trying to bring here. And it's an open invite. I'm willing to contribute to BBF in defining in that framework that interface for broadband access. But I believe we, as BBF community, need to do it. Because a lot of customers I get a lot of RFPs, as you can imagine. Since 1 year, all are referring to TM Forum. All.
Hi there. Got a couple of questions about the slicing. One is, how do you deal with applications which have multiple different workloads and servers? So if I'm playing a game and I've got the CDN I'm getting some of the data from, I've got the voice chat server over there, I'm getting ads from an ad network over here, and essentially lots of other sort of components of the game. Maybe an AI element or a graphics rendering service or something like that. So do you end up having to need 10 slices for that for the one game?
No, a very good question. So.
and the other question.
Yeah, but one by one. One by one. No, I don't want to stop you, but one by one. So Let me stick to the access network, because for the home, we rely on Wi-Fi optimization and its evolutions. So for instance, today we can do it using 2 different SSIDs. But as you know, Wi-Fi 8, 9, 10 is evolving to do actually differentiation within the Wi-Fi channels. Since we are mainly access here, what we do is actually creating other VLANs. It's another VLAN for another type of service. So if you have a gaming service, which you connect through end-to-end slices to, for instance, this is PlayStation, this is Sony Entertainment, we will create in the access network another VLAN, which is then tunneled into another IP route. So it's a separate VLAN. Now, then you can ask, yeah, wait a minute, what about, are you creating a new set of VLANs? Because VLANs are limited to 4K VLANs. That's not the way it works. So it could be that if an operator deploys cloud gaming as a premium service, together with, for instance, Sony Entertainment, and we have such an operator in the US, we will create only one dedicated VLAN with that specific service level agreement to carry over all the gaming traffic. So it's not scaling per user, it's scaling per aggregation. Yeah.
Right, and this is like assuming a walled garden deal with, in this case, Sony or someone like that, rather than in the middle of the transport, you've got an internet exchange, branching out to, okay. The other one is similar, which is for home office. Most businesses will use VPNs. So how are you going to fingerprint my Teams versus my Oracle?
That's, that I cannot answer, actually. So I can, but I cannot, I'm not allowed. Yeah, we look, because, I cannot expose all the secrets we are working on here. Sorry for that.
All right.
Yes, we are able, maybe next time I can do the live demo, as yesterday, I liked it, actually. But yes, we are able to, with high precision, even using digital twin technology in the cloud, to exactly classify what you are using at home.
Inside the VPN?
Yeah. How we do that, that's one of our secrets, right? I hope you understand me, right? But yes, we are able to do that.
Thank you.
With high precision, yeah? So with very high precision. So might be threatening, but yes, we are able to do that. And not with me, I don't mean Nokia only, but the AI technology, which we are working as well with Bell Labs, I'm part of, is able to detect a lot. More than we want, actually.
That sounds like a conference all of its own. That lasts a little bit. So with that, it's 12:45. Lunch started at 12:30, and I heard there's only enough meals for the USP folks. So hopefully, run is what I'm saying. Get there, get some food. But we'll come back after lunch and restart this. And thank you, everyone. Speakers, please come up here, and please give Kurt a hand. Thank you, Kurt.